Hello everyone, today we are going to see RSA algorithm. RSA algorithm is an asymmetric cryptographic algorithm. So what asymmetric means? It can operate on two different keys such that public key and private key both are needed. As the name describes what public key is, public key can be visible by everyone and the private key can be only viewed by authorized user and those who have authorization over it. It was invented in the year 1978 by Rivers, Shamir and Edelman. Hence it got the name RSA algorithm. Let's move on the steps involved in the algorithm. First, we are going to select two large prime numbers and we can name it as P and Q. The second step, we are going to calculate the value of n, which can be calculated by multiplying the prime numbers. The third, we are going to calculate phi of n, that we can be calculated it by using the formula phi of n equal to p minus 1 q minus 1. Then we are going to find the public key value. So before going to find it, it should satisfy the following condition, which is 1 less than e less than phi of n. That is, public key should be greater than 1 and it should be less than phi of n. And GCD of E, phi of n should be equal to 1, which means it should be a co-prime value. Then we are going to calculate the private key value D, which can be calculated by ED equal to 1 mod P minus 1 Q minus 1. It can also be calculated by using a formula D equal to 1 plus K dot phi of n divided by E. We can see it further on the example. Then we are going to do encryption process. So we are going to create a ciphertext. So we need the formula of m power e mod n, where m is the message we are going to send and e is the public key. Then moving to decryption, m equal to cd mod n. We are going to decrypt the message. So we just need the ciphertext and the private key value. Consider the example. First, we are going to choose the two prime number values as p equal to 3 and q equal to 11. In the second step, we are going to compute the n value, which can be computed by p star q, which means 3 into 11, we get answer as 33. In the third step, we are going to calculate the phi of n value using the formula p minus 1 into q minus 1. So here the p is 3 and 3 minus 1 will be 2 and the q is 11. 11 minus 1 will be 10. So product it and we get the answer of 20. In the fourth step, we are going to choose the e value, which is the public key value. So it should be in the following condition: 1 less than e less than phi of n, and e and phi of n should be a coprime. So what is a coprime? A coprime actually means that two numbers e and phi of n should have a common divisor of 1. Except 1, there should be not any other common divisor. Here the public key value e is 7 and the phi of n value is 20. So 7, 20, it has none other common divisor than 1. Moving on to further step, we are going to calculate the d value, either by using the formula ed equal to 1 mod p minus 1 q minus 1 or by an easy method d equal to 1 plus k dot phi of n divided by e. So k can be ranged from 0 to n number values until you get whole number as a result. Let's move on to the steps. First we are going to do k equal to 0. Then going to substitute in the formula, we get answer as 1 by 7, which is a fraction number. So we are going to make k as 1. D equal to 1 plus 1 dot 20 divided by 7. Here we get 21 divided by 7 equal to 3. Hence it is a whole number. We get the private key value, that is the d value is 3. Thus finally we got public key value e n is 7, 33 and the private key is d n, which is 3, 33. We are going to make encryption process. Here the message is 2. So what about making the ciphertext? It can be made by the formula m power e mod n. So here the message is 2 power and the e value is 7 and mod 33 n, where 33 is the n value. Finally, we got the answer as 29, which is our ciphertext. In the decryption process, we have ciphertext value 29 and we are going to decrypt the message as well. So, the formula is C power D mod n. So, the ciphertext C equal to 29 and D value is 3 and the n value is 33. Computing it, we get the message as 2.